Hello and welcome once again to the Akash BYJU'S JEE channel. My name is Atiullah and we are live with the Rankers Batch 2023. So if you want to be a ranker in JEE Main and Advanced 2023, this is the place to be. Alright, a very warm welcome to all of you. So we have people already coming in, very punctual. Truly Satyam, good afternoon, how are you? Good afternoon Ravi, how is it going? How is your preparation going? Alright, are you enjoying these ranker sessions? Do give us feedback, do tell us that what more can we do for you, what is the thing that we are lacking, even we want to improve, what we are doing right, what we are doing wrong. You should give us an honest feedback so that we can help you better. Alright, so what is on agenda today? Motion in one dimension. This is lecture 4. So we are going to look at graphs. Okay, graph is very important for kinematics and in general also graph is very important. Alright, so we have Swastika joining in as well. Hello Swastika, how is it going? How are you? How are things? हम भी आ चुके हैं. Swastika, this time I have come earlier than you. Okay, chalo. Alright, like we say, a picture is worth 1,000 words. Similarly, I say that a graph is worth 1,000 words. So if you're able to see a graph, okay, when I say see, truly see, understanding the graph, there's a lot of information that you can extract from the graph, and if you have a good handle on graph, you can solve questions in a jiffy. You can solve questions in much less than in a much lesser time compared to using equations. Obviously, it's not always true, but a lot of times you will see that the graphical method or the graphical analysis is much more helpful in solving questions. Alright, Swastika बोल रही है बैच अच्छा चल रहा है. I'm trying my best to not miss any class, either attend live or watch video. Very good Swastika. I like your consistency and this is the consistency that I'm expecting from all the students. If you're working with this kind of consistency, there's no reason that you're not going to crack JEE. Alright, all ready? All set? We are ready to roll. Okay, so if you are ready, just give me a thumbs up, give me a yes so that we can start the session, and you should be ready with your notebook and pen because we have to solve all the questions together, as well as you should make your own notes. Alright, स्वास्तिका बोल रही है सर सब टीचर्स के टेलीग्राम ग्रुप में मैंने ज्वाइन किया लेकिन उनमें अभी कोई एक्टिविटी नहीं है. स्वास्तिका, soon you will see activity in those groups as well. Good, you have joined. Alright, chalo. So let's get started. Let's get this thing rolling. So before we get started, just a few announcements. You would have heard of Anthe. So if you know someone who is from class 7 to 12, do tell them about Anthe. There's a lot of rewards that you can win from here. Also, BYJU'S is also conducting a scholarship test. And if you do well, you can get a chance to go to and see ICC T20 World Cup in Australia. Okay, so this is for classes 4 to 10. If you have people from 4 to 10, do tell them about it. And do check out the Akash BYJU'S app. There's top-notch content over there. It's going to be very helpful for you as well. Okay, just check it out once. Alright, chalo. Done with the announcements. One more very important announcement I'm going to make today. Because a lot of people have saying that we don't get a lot of time to practice. We have classes, we are attending sessions, but we don't get a lot of time to practice. So for that, what we are doing is, and especially for physics, because physics is a little different from math and chemistry. In physics, you have to be very good conceptually as well as a lot of practice is required. So because of you guys, we are going to conduct from next week another session just for practice. Okay, so our sessions are on Tuesday, Wednesday, Thursday and Friday. You know that Tuesday and Thursday Mrinal Sir takes class 12th and Wednesday and Friday I take class 11th. Okay, so the regular sessions will happen at 12:30, but from 5 o'clock we are also going to do some practice session. So if you are not getting time or if you want to see some advanced problems, you can solve with us. Okay, so we'll give you time to solve. You can solve with us. Alright, so there's no excuse absolutely for you to not find time and to not be able to solving questions. Okay, question solving is very important. Futures बोल रहा है सर मैं कैसे involved हो सकता हूँ. What do you mean by involve? Okay, you're attending this session, you're already involved. You attend these sessions, you work with us, you are studying and you are involved. Alright, chalo. Without wasting any more time, let's get right into business. तो आज का एजेंडा क्या है? The first thing is we are going to look at displacement and distance time graph. The second thing we are going to look at is the velocity and speed time graph. Then we are going to look at acceleration time graph, and we will also look at the velocity position and the acceleration position graph. Okay. So a lot of times this is neglected. The velocity position graph and acceleration position graph is neglected, but there are many beautiful questions that can be framed on these concepts. All right. So let's get started. Let's get rolling, and quickly we'll see the theory part. Okay. These things you already know, but just a quick reminder. Okay. Let's start with position time graph or displacement time graph. So a lot of times we interchangeably use position time graph or displacement time graph. Now, do you know that the change in position gives us displacement, and the change in displacement also gives us displacement? Okay, स्वास्तिका बोल रही है वो समझने में टफ पड़ता है क्योंकि we don't spend time with that. Yes, absolutely, and that is why we are going to spend good amount of time over here. Okay, so what I'm trying to convey over here is that we can interchangeably use position time graph and displacement time graph. Okay, because the change in position gives us displacement, and the change in displacement also gives us displacement. Okay, the only difference is that position we take from the origin. Okay, so if this is the position R1 and this is the position R2, then this is going to give us the displacement. That is the change in position that is going to give us displacement. Now, when we are talking about displacement, obviously we are talking from a reference point. Okay, that reference point may or may not be the origin, but displacement also is measured from a fixed point. So let's say this is the fixed point. So if the displacement happened like this, let's call it S1, and then this was the displacement later on, then the change in displacement is also going to give us displacement. So a lot of times we write it as dx by dt, but we can also write it as ds by dt. So the change in position or the change in displacement both gives us displacement. So we can interchangeably use position time graph and displacement time graph. Notice that position and displacements are not the same, but the change in position and the change in displacement are the same. They give us the displacement. All right. So I just wanted to emphasize on this fact. Maybe you already knew this, but just for clarity. All right. So what information does the position time graph convey us? Okay. Can you tell me what are the things that we can figure out from the position time graph? Can you tell me? Quickly tell me. You already know these things. I want to quickly get done with this. What can we figure out from the position time graph? So you know this very well, that if we draw a tangent at a particular point, okay, it gives us the slope. Okay, and the slope of the position time graph is going to give us the velocity. Truly Satyam, speed nahi. No, speed nahi, velocity. You were right the first time. Yes, truly Satyam, you are absolutely true. What do we get? We get velocity. Now we can also get the direction of motion. How we can get the direction of motion? Because the slope could be positive, the slope could be negative. Is that correct? So if the slope is positive, like in this case, the particle is moving in the positive x direction, and if the slope is negative, the velocity is negative and the particle is moving in the negative x direction. Is that correct? Okay, chalo. Is there anything else that we can figure out from the position time graph? Brainstorm, think. A graph is worth 1,000 words, right? So there are a lot of things that we can extract from a graph. So I want you to think and tell me, what else can we deduce from the position time graph? There's still many things that we can deduce from a position time graph. Think about it. All right, so Arpit has joined us. Hello, sir. Hello, Arpit. How's it going? Swastika is saying location in a 3D space where some reference point is taken as origin. Correct. Swastika, you are right. Okay, sir, if there is problem, then it should be speed, and when displacement, then velocity. I could not really understand the question, Satyam. Sir, if there is position, then it should be speed, and when displacement, then velocity. No, Satyam. No. Change in position also gives us displacement. Change in displacement also gives us displacement. So instead of the position time graph, if we had the displacement time graph, even then we'll get velocity. Now, when you are going to get speed, we are also going to talk about it. You are going to get speed when there is distance time graph, right? Because the slope of the distance time graph is going to give you the speed. ठीक है, तो इसमें confuse नहीं होना है. Swastika is saying displacement. Obviously, Swastika, displacement तो पता चल ही जाएगा. We know the initial position, we know the final position. तो वहां से we can get the displacement as well. You are absolutely right. But there is something else also. Think hard. Prakhar is saying, sir, can we get instantaneous velocity also from graph by drawing tangent from origin to that point? Origin to that point. See, Prakhar, you are talking about a time interval. When you are talking about origin and a particular point, you are talking about a time interval. So for this time interval, if you find the slope, this is going to give you the average velocity. Is that correct? For instantaneous velocity, it has to be a tangent at a particular point. Is that correct? Okay. Dishant is saying, sir, is the session also for droppers? Yellow. Dishant, this session is for droppers. This is specially for droppers, but also for people class 11th and 12th who want to go a level beyond what they are studying. Then this session is for them as well, but this is specifically for droppers. Okay. All right. Swastika is saying, if initial position is not 0, then displacement is not equal to position. That is right, Swastika. That is right. ठीक है? उसमें कोई problem नहीं है, but we are not comparing the position and displacement. Obviously, they are different things, but we are saying the change in position and the change in displacement, both are going to give us displacement. All right, Dishant, you are new here, no worries. Okay, welcome, dude. Welcome to this session. So this session is specially for droppers. So you are at the right place if you are thinking of dropping or you have already dropped. And we don't call people droppers here, we call them rankers, because if you and I work together, we are going to become, or we are going to make you and you're going to become a ranker. Okay. नहीं answer नहीं आ रहा है यार मेरे को. The answer that I am looking for. I am not going to move forward until I get the answer. ठीक है? This is not this is not any usual batch. This is a rankers batch. So you guys have to give me the correct answer. Okay, the basic things you guys have to brainstorm. You guys have to work hard and then tell me. Okay, I'm not moving forward like this. Okay. स्वास्तिका बोल रही है, the graph tells us about position velocity. और क्या बताएगा, दिमाग में नहीं आ रहा है. स्वास्तिका, यही तो दिमाग लगाना है. चलो, अब कुछ दिमाग में आ रहा है. Sir, is this session based on AOD? AOD, do you mean application of derivatives? Kamlesh is asking, is the session based on AOD? Yes, Kamlesh, a part of it, because obviously when we are talking about graphs, yes, application of derivatives would be used. Okay, we would be using the tangent. Okay, we would be using the differential. We would be using the integral when we are talking about the area under the curve. हाँ जी, अब चमका. ठीक है, double differential makes it acceleration. Okay, so acceleration is delta v by delta t or d square x by dt square. यानी slope का slope. You're getting it? Slope ka slope in this case is going to give us acceleration. Okay, maybe calculating acceleration numerically would be a little challenging, would be a little difficult, but the nature of acceleration we can figure out by simply looking at the change in velocity or the change in slope. Is that right? अब दिमाग की बत्ती जली? अब समझ में आया? ठीक है? So this information as well, and sometimes we forget. ठीक है? So this information also we can derive from a position time graph or a displacement time graph. Is that correct? All right. Let's understand how. Okay, so what I'm going to do is I'm going to show you graphs. Okay, and with those graphs there are a few questions. So you need to tell me. I'm not going to tell you. I'm not going to teach anything today. Okay, I want to know from you. Okay, what all can we deduce from a position time graph? You can see a lot of things. So you guys are going to tell me how. First is direction of motion. Second is velocity. Third is acceleration and type of motion. So in the bracket, you are going to see the option. For example, the direction of motion could be positive or negative, constant or variable, positive or negative, etc. Is that correct? ओके, स्वास्तिका बोल रही है क्या सर डायरेक्टली इस ग्राफ से एक्सेलरेशन थोड़ी ना पता चलेगा, ये तो चीटिंग है। क्यों नहीं पता चलेगा स्वास्तिका? अगर मैं वैल्यूज दे दूं तो क्यों नहीं पता चलेगा? इफ आई गिव यू द वैल्यूज, ठीक है, फॉर एग्जाम्पल आई गिव यू द वैल्यूज एंड आई आस्क यू कि दिस पॉइंट एंड दिस पॉइंट के बीच में कैन यू टेल मी व्हाट इज द एक्सेलरेशन? इफ आई आस्क यू दैट, सो व्हाट यू आर गोइंग टू डू इज यू आर गोइंग टू ड्रॉ अनदर टेंजेंट, ठीक है। सो दिस टेंजेंट से you get the initial velocity, this tangent से you get the final velocity and you know the time interval between the two. तो acceleration क्यों नहीं निकलेगा? If I give you the values, acceleration निकलेगा बाबा, ठीक है, but it is going to be a little tedious. Generally the numerical value of acceleration is not asked, but the nature of acceleration can certainly be asked. Is that correct? चलो, so let's start. Okay, let's start. Okay, so if I'm going to ask you a question, you're going to quickly give me the answer. 5 seconds. So start. Direction of motion. Tell me what is the direction of motion and why. ऐसे नहीं छोड़ूंगा. Direction of motion and why. Let's go one by one. Let's go one by one. I'm asking about direction of motion. Quickly tell me, is it going to be positive or negative and why? Swastika is saying positive direction. Swastika, why? Direction of motion, positive or negative? Positive. Prakhar is also saying positive. But why? Ravi is also saying positive. Truly Satyam is also saying positive. As it is going upwards. Satyam, iska kya matlab? Going upward. Because it is increasing with respect to time. Increasing slope, acute angle. Oh ho. ठीक है, बहुत सारा डिफरेंट तरह का आंसर अपने को मिल रहा है. ओके, तो थिंक, हाउ डू वी हैव टू थिंक? ठीक है, सोचो, हाउ डू वी हैव टू थिंक? वी हैव टू थिंक इन टर्म्स ऑफ स्लोप. पहली चीज, वी हैव टू थिंक इन टर्म्स ऑफ स्लोप. ओके, नाउ व्हाट डज द स्लोप गिव? इफ आई कैलकुलेट द स्लोप, what is it going to give us? It is going to give us the velocity. Is the slope constant? Is the slope positive or negative? The slope is positive. It is making an acute angle with the time axis. So what is the slope? This slope is positive, meaning the velocity is positive, which means the particle is going in the positive direction. Is that correct? So what will be the correct answer? Positive. ठीक है, ऐसे भी देख सकते हो, ऐसे भी तुम देख सकते हो कि the x is increasing. ठीक है, पहले x यहां था, अब x यहां पे है. So x is also increasing, which means that the particle is going in the positive x direction. But I want you to concentrate on the slope. Is that correct? Clear? चलो, Chunnu has joined us. Hello, Chunnu, how are you? Okay, next. Velocity, constant or variable? Swastika, your answer is absolutely right. But the reason, and your reason is also right, okay, because slope does not change. Correct? So how do we know that the slope does not change? Because the slope is constant, because we see a straight line and the slope is constant. Is that correct? Which means, what is this? It means that the velocity is going to be constant. So constant is going to be our correct option. Okay, Arjun is saying, sir, sorry for disturbing. I want to know that in GB, sir, special case will be complete entire 11 and 12 course. Arjun, I don't know about that. I'm sorry, I don't know about that. Maybe you can check with someone in the math session. Okay. All right, next, acceleration. What can we tell about the acceleration? Okay, people have already started giving answer. Roshan Chaurasi is saying acceleration is 0. Prakhar is saying acceleration is 0. Velocity is constant, motion is uniform as the position time graph is linear. Bang on. ठीक है? तो velocity कैसे पता चल? So velocity is what? Velocity is constant. Because I see that the slope is constant, and if the velocity is constant, what does it mean? It means acceleration is equal to 0. Correct? Okay. Then what is the next one? The next one is type of motion. The type of motion, is it accelerated or is it decelerated? Mahjabin is saying it can be both, sir, positive and negative in case of retardation. Mahjabin, we are talking about this particular scenario. Okay, we are talking about this particular scenario. In this case, there is only one correct answer. Okay, now what are we talking about? We are talking about the time of motion. Accelerated or decelerated? Quickly tell me. The motion is accelerated or decelerated? Okay? The acceleration is 0, which means this is uniform motion. So the type of motion is going to be uniform motion. Is that correct? Clear? Any problem? Chalo, perfect. So now you know how to think. Okay? Now you know how to think. Obviously, this is a very simple example. The examples are going to get slightly more trickier as we go ahead. Okay, I hope you are able to see the graph. Are you able to see the graph? Okay, chalo, start. Let's start. Let's go with direction of motion quickly. Let's start. Number 1, direction of motion. What is the direction of motion? Negative. Swastika is saying negative. Guys, quickly, what is the direction of motion? Direction of motion is negative. Robin Roy is asking, sir, ये क्या पूरा पैटर्न पीडीए रहे हो? ये तो हम नहीं पढ़ रखा है. Robin, I'm not sure what you are asking, but we are talking about graphs. If you have not seen the previous lectures, you can go to Akash BYJU'S JEE channel, go search the playlist, and you are going to see the things. Okay, you are seeing the previous lectures. ठीक है. Direction of motion क्या है? Negative, because the slope is negative. Is that correct? The slope is negative. So the direction of motion is going to be negative because velocity is negative. Next, velocity is constant or variable? Chalo, batao fatafat. Velocity is constant or variable? Quickly guys, tell me. Velocity constant or variable? Velocity is uniform. Okay, very nice. Because the slope is constant. How do we know the slope is constant? Because it is a straight line. So the slope is constant. So velocity is going to be constant. ठीक है, चलिए अब एक्सेलरेशन के बारे में बताइए. No acceleration again. चलो guys, quickly tell me about the acceleration. Swastika, you are absolutely right. Graph is linear. मतलब velocity is constant. So if velocity is constant, the acceleration is going to be 0. And what will be the type of motion? The type of motion again is going to be uniform. Right? चलो, excellent. Abhishek is saying, sir, एक बार repeat कर दो ना. Abhishek, you have joined late in the session. I can't repeat the whole thing. So when the session ends, you can go back. It will be on YouTube. You can check again. Okay? No problem. Okay, तो हाँ अब तक सकती हूँ कि tells qualitatively about acceleration. Yes, yes. आएगा और भी आएगा. I'm giving you more examples, Swastika. Don't worry. चलो अब इसमें बताओ. अब इसमें बताओ direction of motion क्या है? Priyesh, hello, how are you? Why is joining the session late? Baba, join on time. Chalo guys, tell me, what is the direction of motion in this case? Ab dikh raha hai? Position time graph. Truly Satyam is saying positive. Truly Satyam is saying positive. Swastika is saying positive. Prakhar is saying accelerated. आएंगे Satyam, Prakhar, we'll come to acceleration. Baba, आराम से एक एक करके, don't worry. We'll cover everything. There's no need to rush. ठीक है? The direction of motion is positive. How do we know the direction of motion is positive? Quickly tell me. How do we know the direction of motion is positive? For the entire motion, the direction of motion is positive. By tangent. Very good, Prakhar. Yes, so if we draw a tangent at any point, what do we see? That all these tangents are positive. Is that correct? If we draw tangent at any point, we see all these tangents are positive, which means that the velocity is positive always. In this case, the velocity is always positive, which means the direction of motion is always going to be positive. Is that correct? Okay? Very good. Now tell me, velocity is constant or variable? फटाफट बताओ. Velocity is constant or variable? Velocity is constant or variable? What do you think, guys? Variable. Obviously, Ankush is saying variable velocity. Obviously, because the slope is changing. The slope at every point is changing. So, obviously, it is variable velocity. Very nice. Now, tell me about the acceleration. Is the acceleration positive or negative? Is the acceleration positive or negative? Swastika is saying positive acceleration. Swastika, explain. Why positive? Disha is also saying positive acceleration. Everyone is saying positive acceleration. Can you explain? I'm not talking about ठीक है, don't get confused by type of motion, accelerated or decelerated, don't get confused about that, ठीक है, because concave up graph, Swastika is saying non-linear graph. Swastika, if non-linear graph is there, can we say acceleration is positive? Ankush is saying because slope is acute. Prakhar is saying double derivative tells about concavity. Prakhar is absolutely right. Excellent answer, Prakhar, and that is what I was looking for. Okay? We'll have to look at the concavity of the graph. Okay? Chalo, let me explain this to you. If you already know this, great, but if you don't know this, let me explain it to you. Okay? Swastika, non-linearity to hai. That's for sure, which means that the velocity is variable, which means acceleration will be there. Okay? But we need to find out when is the acceleration positive and when is the acceleration negative. We are only talking about the direction of acceleration. We are not talking about whether the motion is accelerated or decelerated. We are only talking about the direction of acceleration. Okay? Chalo. Let's say the graph is like this. Let's say that the graph is concave upwards. Okay? So if we take a slope here, what is this going to be? This is going to be, or let's say we take a slope over here. So this slope is going to be what? This slope is going to be positive and it is going to be a high positive. Let's say, let's assign it some value. Let's say 4. And let's say we take a point over here. And this slope, what do we see about this slope? Okay, what do we see about this slope? It is making a lesser angle. Okay, so slope jitna, tangent jitna vertical hoga, स्लोप का मैग्नीट्यूड उतना ज्यादा होगा, टेंजेंट जितना सोया हुआ होगा, स्लोप का मैग्नीट्यूड उतना कम होगा, है कि नहीं? So what do we get here? We get a positive slope, but the magnitude is smaller. Let's give it some value. Let's say 2. Now what is the change in velocity? What is the change in velocity? The change in velocity is 4 minus 2, which is positive. Is that correct? So what do we see? That the change in velocity is positive, means the acceleration is going to be positive. Is that correct? You can do the same thing over here also. You can do the same thing over here also. Okay? How? So let's give it something. So now what is this? This is a negative slope. Okay? This is a negative slope. What am I talking about? I'm talking about the slope over here. It is a negative slope, but this slope is more vertical, which means it has a high magnitude and it is negative. So let's assign it, let's say minus 4. And what about this point? It has a slope which is lesser in magnitude. Slope क्या हुआ है? सोया हुआ है. ठीक है? The tangent थोड़ा सोया हुआ है. So what does it mean? It means that the slope is negative, but it is also low in magnitude. तो low in magnitude minus 2 दे देते हैं. Now you find the change in velocity. If you find the change in velocity, this is going to be minus 2 minus minus 4, and this is going to be equal to positive. Is that correct? So किधर से भी check करना है कर लो. But what do we understand? If the slope is, if the graph is concave upwards, then the double differential is going to be positive. Is that correct? ठीक है? And सिर्फ double differential की बात नहीं है. We can check. So it's not necessarily a parabola. ठीक है? जरूरी नहीं है कि आपका जो ग्राफ हो वो parabola हो. It's not necessary. Okay? But whenever we have a case where the graph is concave upwards, what does it tell us? It tells us that the double differential is going to be positive. ठीक है? Maxima minima में भी आपने ये पढ़ा होगा, but I just wanted to explain this to you. ठीक है? So if the slope, if the graph is concave upwards, acceleration will be positive. If this graph is concave downwards, the acceleration is going to be negative. ठीक है? Disha is saying, sir, can we get a graph of a cubic function? Yes, absolutely, Disha. You can get a graph of a cubic function also. But उस case में भी what will happen? उस case में भी the double differential is going to decide whether the slope is whether the double differential is positive or negative, whether the graph is going to be concave upwards or concave downwards. ठीक है? Is this clear? So is this clear? If the graph is concave upwards, the acceleration is going to be positive. If the graph is concave downwards, the acceleration is going to be negative. So from here we can tell the direction of acceleration. Is that correct? Any problem? Clear? सबको clear है ये? चलो, perfect. Now let's talk about the type of motion. Is it accelerated or decelerated? Quickly tell me if the motion is accelerated or decelerated. Now you remember that the direction of acceleration has nothing to do with the accelerated or decelerated motion. Is that correct? The direction of acceleration or the sign of acceleration only tells us direction. Whether it is accelerated or decelerated depends on what? Tell me. Whether a motion is accelerated or decelerated depends upon what? Swastika is saying accelerated. Alright, yes Swastika, you're right. But tell me the reason. Tell me the reason. Why do you think this motion is accelerated? I know you can figure all these things out, but I want to go in a lot of detail. पूरा concept मुझे clear कर देना है कि कभी आपको इसमें problem हो ही नहीं. Disha Bhatt is saying slope either positive or negative. दिशा समझ में नहीं आया मुझे. Change in speed is positive. Change in speed is positive. ठीक है, simple है, बहुत simple है. Type of motion is going to be accelerated if the speed increases. If the magnitude of velocity increases, what will happen? It will be accelerated motion. तो हमें क्या देखना है? Slope का magnitude देखना है. Is that correct? We have to only look at the slope का magnitude. Here the slope का magnitude is less because सोया हुआ है. Here the slope का magnitude is more because it is more vertical. Is that correct? ठीक है? So what is happening? The velocity, the magnitude of velocity is increasing, the speed is increasing, and when the speed is increasing, we can say that this is accelerated motion. Is that correct? Clear? Perfect. Truly Satyam, del V is positive, so it is accelerated. Correct, correct, bilkul. You all are saying the right things, but I am showing you how to directly see it from the graph. ठीक है, सीधे ग्राफ में दिखा और बता दिया. What is happening? The magnitude of slope is increasing, matlab the speed is increasing, matlab it is getting it is getting accelerated. Correct? दिशा बोल रही नो सर आप पूछ रहे थे ना हाउ टू फिगर आउट उसका आंसर. ऑलराइट दिशा, ऑलराइट, कूल कूल कूल, नो प्रॉब्लम. ठीक है, चलो क्लियर है. तो if we have to see accelerated or decelerated motion, what do we have to see? We have to see the speed, which means we have to look at how the slope, the magnitude of slope is changing. Chalo, next one. Quickly tell me the direction of motion. Next graph, guys, quickly tell me what is the direction of motion, positive or negative? Quickly guys, positive, direction of motion positive. I need more answers. More answers. Roshan Chaurase is saying negative. Ooh, Roshan, why? Swastika, because it is increasing. What is increasing? Roshan Chaurase is saying positive, positive. Very good. ठीक है, स्वास्तिका एक एक करके चलते हैं. डोंट रश. आई नो यू आर इन अ रश टू फिनिश ऑल दिस ऑफ, बट एक एक करके चलते हैं, अदरवाइज डिस्कशन थोड़ा मुश्किल हो जाता है. ठीक है, विल टॉक अबाउट ईच एंड एवरीथिंग, सारा पढ़ेंगे, बट वन बाय वन. ठीक है, यस, दैट इज द करेक्ट आंसर. ठीक है, बिकॉज द स्लोप इज ऑलवेज पॉजिटिव. ठीक है, you make a slope over here, you make a slope over here, the slope is always positive, which means that the direction of motion is always positive. Is that correct? Perfect. Yes, 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 absolutely great. All of you are giving good answers, great answers. Chalo, next let's talk about velocity. अब velocity के बारे में बताओ. Is the velocity constant or variable? फटाफट बता दो, इसमें तो अब दिमाग लगाने की बात ही नहीं है. Is the velocity going to be constant or variable? Positive as position with respect to time is increasing. That is also a correct answer. Truly Satyam is saying negative. Negative what? We are talking about velocity, constant or variable. Baba, एक एक करके चलते हैं. Don't rush. Let's finish one point and then go ahead. ठीक है? Yes, variable velocity, obviously, because the slope is changing. It is variable velocity. Very good. अब बताओ मुझे acceleration positive है या negative है? Disha is saying, sir, I have a doubt. पूछो Disha, tell me what is your doubt? हाँ. Now I'm asking, what is the acceleration, positive or negative? Prakhar is saying negative. Roshan Chaurasia is saying negative. Mehjabin is saying negative. Swastika is saying negative. Absolutely wonderful. Why is it negative? Because the slope is convex upwards, or we can say that the slope is concave downwards. So the acceleration is going to be negative. Disha is asking, sir, uniform velocity gives zero acceleration or constant acceleration. Think Disha, uniform velocity है, तो change in velocity क्या होगा? Change in velocity is going to give you zero. Okay, so it is going to be zero acceleration. Correct? Now zero is also a constant, so you can also say constant, but zero is the correct answer. All right. Chalo. Next, acceleration, positive or negative, we have seen. Now the type of motion, accelerated or decelerated. Chalo guys, quickly. The type of motion, accelerated or decelerated. Swastika is saying deceleration because the slope is decreasing. Very good. Prakhar is saying decelerated. Perfect. You guys have absolutely understood this. And Rachit is saying, sir, mera nahi aaya. Kya nahi aaya, baba? Ye to batao. Kya nahi aaya? Sir, when do we get constant acceleration then? Like for given the interval, we'll talk about it, Disha. Don't worry, we'll talk about it. We'll talk about it. Okay. The tangent slope is decreasing, so it is decreasing. Absolutely. So the tangent was more vertical, now it is more sleeping. Okay. So what is happening? The magnitude of slope is decreasing, matlab the speed is decreasing. So this is going to be a decelerated motion. Is that correct? Chalo. Next. Ab batao. Fatafat. What is the direction of motion? What is the direction of motion? Negative. What is the direction of motion in this case? Negative, negative. Excellent, guys. Excellent. Excellent. So you can see that the slope is always negative. Disha, negative as slope decreases. Na. We are not talking about the change in slope. Disha, समझो इस बात को. We are not talking about the change in slope. We are just talking about the slope. Velocity किससे पता चलता है? Slope से. So what is the slope over here? The slope over here is negative. The slope here is also negative. All throughout the graph, the slope is negative. मतलब the velocity is negative. मतलब it is going in the negative x direction. ठीक है? So direction of motion negative. What about velocity, constant or variable? Velocity, constant or variable? Obviously the velocity is variable, right? Perfect. Perfect. You can see the slope changing. Yes, absolutely. Now tell me acceleration is positive or negative. Now tell me acceleration is positive or negative. Prakhar is saying positive accelerated. Iska kya matlab hua, Prakhar? Can you explain what does positive accelerated mean? Okay, I'm talking about acceleration being positive or negative, meaning I'm talking about the direction of acceleration. So the direction of acceleration is negative. Very good. Why the direction of acceleration is negative? Because this graph is concave downwards. Is that correct? This graph is concave downwards. So that is why the acceleration is going to be negative. Yes, all of you are getting this absolutely right. Now tell me, what is the type of motion, accelerated or decelerated? Ab batao. The motion is accelerated or decelerated. Prakhar is saying accelerated. Vaibhav is saying decelerated. There is a conflict over here. Let's resolve the conflict. Direction of acceleration is the same as that of velocity. Negative. Speed is increasing. Yes, absolutely. Absolutely. Roshan Chaurasia, retardation. सोच के बताओ. Roshan, think. Disha is saying accelerated motion. Sir, slope का angle decrease कर रहा है. Yes. Absolutely. Wonderful answers. Wonderful answers. So we are explaining the same thing, but look, you guys have explained it with so many different ways. Okay, amazing. Very nice. ठीक है. So simply what do we have to see? We have to see कि slope के magnitude के साथ क्या हो रहा है. Slope का magnitude क्या देता है? Slope का magnitude gives us the speed. Correct? Velocity का magnitude क्या देता है? Speed. Correct? So we have to look at the slope का magnitude. So the slope का magnitude here is small. The slope का magnitude here is large, which means that the motion is accelerated. The speed is increasing. It is accelerated. So another example Another example where acceleration is negative but the motion is accelerated, right? We discussed it in the previous lectures. Another example where the acceleration is negative but the type of motion is accelerated. Okay? So this is an example where you can see it from the graph. Why did it happen? Because the direction of motion was negative, the acceleration was also negative, so obviously the particle is going to accelerate, its speed is going to increase. Is that correct? Disha is asking, sir, am 2024 batch, can I attend? Yes, Disha, you are doing very well here. सब तो समझ में आ रहा है तुमको. Even if you are from 2024 batch, you are still understanding everything. You can attend this session. Not a problem at all. Rakhi has joined us. Hello Rakhi. बहुत late आए हो Rakhi. You should come on time. ठीक है? चलो. Last one. चलो फटाफट करेंगे. इस बार सारा आंसर एक साथ बता दो. 10 seconds. 10 seconds. एक लाइन में सारा आंसर बता दो. ठीक है? I'm giving you 10 seconds. In one line, answer everything. All the 4, answer everything. Disha is saying, I have idea about this chapter, but just getting used to it. हाँ, ठीक है Disha. You are here, you are going a level up. सब समझ में आएगा. And you are answering correct. ठीक है? You are giving correct answers, which is brilliant. ठीक है? Even though you are in 11th and this is a rankers batch, you are still giving the correct answers. That is very good, Disha. You should keep attending these sessions. Truly Satyam also. Yes, you are also giving all correct answers. Very good. Continue. Negative variable positive accelerated. Negative variable positive accelerated. Oh, I want more answers. 2 answers have matched completely. Negative variable positive accelerated. See Disha. Bang on. Swastika is saying positive acceleration means accelerated. Na baba, Swastika. क्या बोल रही हो? Positive acceleration means accelerated. Really? Think about it. Think about it. अभी तुमने उससे पहले you had countered this. Now you are saying this. Think about it. Negative variable, negative deceleration. अच्छा चलो देखते हैं. चलो देखते हैं. ठीक है? Deceleration भी हो सकता है. चलो. Now see. Now you saw this graph and within 10 seconds you were able to answer all of this. This is what was my objective. Okay? This was absolutely my objective. Okay? You look at the graph and the graph speaks to you. Hasn't it spoken to you? Okay? In 10 seconds you were able to figure out all these things. Is that correct? चलो फटाफट कर लेते हैं. What is happening? The slopes are all negative. Is that correct? So the direction of motion is going to be negative. The slope is changing, which means that the velocity is variable. The graph is concave upwards, which means that the acceleration is positive. And the type of motion, what is happening? The speed is decreasing. The speed is decreasing, which means this is decelerated motion. Is that correct? Is that correct, guys? ठीक है? Prakhar is saying retardation and deceleration are same thing. Yes, Prakhar, you are right. Retardation and deceleration are the same thing. यहाँ retardation है, deceleration थोड़ी ना है. Swastika is the same thing. Retardation or deceleration is the same thing. Think about it. चलो. How decelerated समझ नहीं आ रहा है सर. ठीक है. Let me explain. ठीक है. Hang on, guys. रुक जाओ. आराम से. Let's think about it again. Now acceleration is a physical quantity. ठीक है? Acceleration is a physical quantity. Okay? When acceleration is positive or negative, what does it tell us? So write down in the comment. Acceleration being positive or negative, what does it mean? Okay, I'll clear the confusion. Swastika, I'll clear the confusion. ठीक है? There are 2 things. आराम से समझो. There is a quantity called acceleration. ठीक है? There is a quantity called acceleration. Now acceleration can be positive or negative. ठीक है? There is a physical quantity called acceleration. The acceleration can be positive or negative. Okay? What does it mean? It simply tells us It simply tells us that what is the direction of acceleration. It simply tells us what is the direction of force. Is that correct? ठीक है? Give me a yes if you understand the first part. I'll explain the second part. पहले ये मेरे को बताओ. Acceleration is a physical quantity. It could be positive, it could be negative. If it is positive or negative, what does it mean? It simply means the direction of acceleration. In what direction are you pushing? The acceleration is in this direction, which means I'm pushing like this. The acceleration is in this direction, which means the push is like this. बस और कोई मतलब नहीं है. Acceleration positive या negative होने का और कोई मतलब नहीं है. The only thing it means is that what is the direction of acceleration, nothing else. Now let's talk about type of motion. Now when we talk about type of motion, then we can say that either it is accelerated motion or whether it is decelerated or retarded motion. ठीक है? अब clear है? Now when we are talking about the type of motion, what does it mean? It could either be accelerated when the speed is increasing. If the speed is increasing, no matter what the direction of acceleration is, I don't care about the direction of acceleration. ठीक है? If the speed is increasing, it is going to be an accelerated motion. Is that correct? And if the speed is decreasing, I don't care about the direction of acceleration. If the speed is decreasing, then it is going to be a decelerated or retarded motion. Both mean the same thing. Okay? It means the same thing. Decelerated or retarded motion, it means the same thing. Is that correct? अब clear है? ये दोनों separately समझ में आ गया? Give me a thumbs up if this is clear. These two are different things. इनको आपस में जोड़ेंगे. Don't worry, इनको आपस में जोड़ेंगे. But Roshan is saying speed. अरे बाबा, magnitude of velocity is the same as speed. ठीक है? Magnitude of instantaneous velocity is the same as speed. तो magnitude of velocity बोल दो या speed बोल दो. Obviously I'm talking about instantaneous. तो है. ठीक है? Swastika, is this clear? योगेश is saying, सर ये भी कह सकते हैं कि टाइम और मोशन ऑपोजिट है. टाइम बाबा, टाइम और मोशन क्या होता है? टाइम कैसे ऑपोजिट हो जाएगा? ऑलराइट, चलो. ट्रूली सत्यम is saying, सर it is not necessary to have the graph below the time axis negative. अरे बाबा, टाइम एक्सिस किधर नेगेटिव है? टाइम एक्सिस इधर है. टाइम कैसे नेगेटिव हो जाएगा? टाइम कैन नॉट बी नेगेटिव. ठीक है? टाइम इज ऑलवेज गोइंग टू बी पॉजिटिव. तो टाइम एक्सिस किधर नेगेटिव है? पोजीशन इज नेगेटिव. दिख रहा है? तो पोजीशन इज नेगेटिव. टाइम कैसे नेगेटिव होगा? ठीक है, चलो. अब ये दोनों चीज क्लियर है. अब लेट्स कनेक्ट दीज टू थिंग्स. लेट्स कनेक्ट these two things. If velocity and acceleration are in the same direction, if velocity and acceleration are in the same direction, the motion will be accelerated because the speed is going to increase. If velocity and acceleration both are positive, or velocity and acceleration both are negative, in both the cases we'll get accelerated motion because the speed is going to increase. Is that correct? When velocity and negative are in opposite directions, the speed is going to decrease and it will be called the decelerated or the retarded motion. Correct? अगर velocity positive है, acceleration negative है, तो retardation या deceleration होगा. Velocity negative है, acceleration positive है, तो भी retardation या deceleration होगा. ठीक है? चलो. Now guys, now tell me if this is absolutely clear once and for all. Tell me guys, give me a thumbs up if this is absolutely clear. अब कोई confusion है कि नहीं है? Tell me. If there is no confusion now, if this is absolutely clear, सारी कहानी, then give me a thumbs up. Disha is saying, so direction of motion is equal to direction of velocity. Yes, Disha, absolutely. Absolutely. Acceleration is rate of change of velocity, not rate of change of speed. That is also correct. Cool. नो सर ये ग्राफ में कैसे आ रहा ये बताइए. ठीक है, चलो अब इस ग्राफ को एक्सप्लेन करते हैं. ये क्लियर है ना? चलो अब इस ग्राफ को एक्सप्लेन करते हैं. ठीक है, फॉर द लास्ट टाइम एक्सप्लेन करते हैं. चलो, डायरेक्शन ऑफ मोशन. हाउ डू विल वी गेट डायरेक्शन ऑफ मोशन? डायरेक्शन ऑफ वेलोसिटी. Slope, what is happening? What is the slope here? The slope is negative or positive? The slope is negative. What is the slope here? Negative or positive? The slope is negative. For all the motion, the slope is negative, which means the velocity is negative, which means the direction of motion is negative. Is that correct? Clear? Chalo, next. Variable or constant velocity. The slope is like this here. The slope is like this here. Is the slope changing? Which means that the velocity is changing, which means that the velocity is variable. Correct. Velocity is, the slope is changing, which means the velocity is changing, so the velocity is variable. ठीक है? Correct. Next, acceleration, positive or negative. Now this graph is concave upwards. This graph is concave upwards. What does it mean? It means that the acceleration is going to be positive. Only I'm talking about the direction of acceleration. ठीक है, एक्सेलरेटेड मोशन, डिसेलरेटेड मोशन ये बाद में देखेंगे. पहले हम क्या देख रहे हैं? एक्सेलरेशन, डायरेक्शन ऑफ एक्सेलरेशन, पॉजिटिव और नेगेटिव, बिकॉज दिस ग्राफ इज कॉन्केव अपवर्ड्स. आ गया एक्सेलरेशन पॉजिटिव. नेक्स्ट, व्हाट इज द टाइप ऑफ मोशन? व्हाट इज हैपनिंग टू द स्पीड? हियर व्हाट इज द स्पीड? द मैग्नीट्यूड ऑफ स्लोप इज हाई. नाउ द मैग्नीट्यूड ऑफ स्लोप इज लो, which means that the magnitude of velocity is decreasing, which means that speed is decreasing, and if the speed is decreasing, it is going to be a decelerated or retarded motion. Is that correct? चलो अब बताओ सब क्लियर है कि नहीं है? अगर क्लियर है तो give me a thumbs up quickly. Truly Satyam is saying, sir, I meant that if the curve is below time axis, the slope is not need necessary to be negative. हाँ, correct. Satyam, you are absolutely right. If the graph is below the time axis, does not mean that the slope is necessarily going to be negative. पिछले केस में ऐसा कहाँ था? पिछले केस में slope positive था. Even the graph was below the time axis, the slope was still positive. है कि नहीं है? Slope का positive कैसे देखना है? Sorry, in this case the slope was negative. अच्छा, we don't have that example, but we can have that example. कोई बड़ी बात नहीं है. We can have that example. कैसा होगा वो example? ठीक है, slope कैसा होना है? Slope positive होना है. ग्राफ ऐसा जा रहा है. चलो. Now in this case the slope would be positive. है कि नहीं? चलो, clear? Okay. Perfect. प्रखर बोल रहा है, sir, if it would have been parabolic, then the motion would have been accelerated at slope is changing from negative to 0 to positive. Parabolic. तो प्रखर यहां पे we are not necessarily talking about parabolic. ठीक है, ये कोई भी फंक्शन हो सकता है. It could be any function. But the thing which is clear is that if the graph is concave upwards, the acceleration is going to be positive, the double differential is going to be positive, and if the graph is concave downwards, then the double differential is going to be negative. मतलब acceleration is going to be negative. Disha is asking, sir, direction of velocity is not always direction of acceleration. Not necessarily, Disha. No, not at all. Not necessary. स्वास्तिका is saying, पिछले केस में deceleration होना चाहिए था. चलो पिछला केस देख लेते हैं. नहीं, how स्वास्तिका? पिछले केस में deceleration क्यों होना चाहिए था? Think. This slope, what is happening to this slope? This slope is लेटा हुआ है ना? This slope is लेटा हुआ. मतलब the magnitude of slope is less. What is here? The magnitude of slope is more. तो decelerated motion क्यों होगा? Accelerated motion होगा. Clear स्वास्तिका? Rate of change of velocity is negative. चलो, स्वास्तिका, you yourself have answered your question. If the rate of change of velocity is negative, then the acceleration is negative. Acceleration का positive और negative होना क्या बताता है? हाँ, here is the conceptual error. Yes, स्वास्तिका. The rate of change of velocity is negative, 100% correct. But that tells me the direction of acceleration, not whether the motion is accelerated or decelerated, right? If the motion being decelerated or accelerated will depend how the speed is changing, correct? Now you have complete concept clarity. Disha ने बोला sir direction of motion is also negative and acceleration is also negative, that's why accelerated. Yes Disha, bang on. सब समझ में आ रहा है अब. Very good Disha. चलो परफेक्ट, क्लियर है अब. फाइनली आगे बढ़ने से पहले, इफ दिस इज एब्सोल्युटली क्लियर, एक्सेलरेशन की कहानी, डिसेलरेशन की कहानी, रिटार्डेशन की कहानी, पॉजिटिव नेगेटिव होने की कहानी, पोजीशन टाइम ग्राफ की कहानी, इफ एवरीथिंग इज क्लियर, गिव मी अ थम्स अप, गिव मी अ थम्स अप क्विकली. चलो, Majabin has given me a thumbs up. Vedant Pandit is saying no. तो बताओ वेदांत, what is the problem? Where is the problem? I think you joined late. फिर से एक बार सेशन देख लेना पूरा. दिशा is saying yes. वेदांत is saying, अरे no से yes हो गया, पॉलिटिशियन बन गया है वेदांत. Tell me one thing. चलो ठीक है, perfect, 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 amazing guys. चलो, now let's go with the next thing, the distance time graph. ठीक है, अब मेरे को बताओ डिस्टेंस टाइम ग्राफ में क्या होगा. वेरी सिंपल, द स्लोप ऑफ द डिस्टेंस टाइम ग्राफ इज गोइंग टू गिव अस व्हाट, द स्पीड, है कि नहीं. हियर वी आर नॉट टॉकिंग अबाउट द डिस्प्लेसमेंट टाइम ग्राफ, वी आर टॉकिंग अबाउट द डिस्टेंस टाइम ग्राफ. सो द स्लोप ऑफ द डिस्टेंस टाइम ग्राफ इज गोइंग टू गिव अस स्पीड. एब्सोल्युटली, द स्लोप ऑफ द डिस्टेंस टाइम ग्राफ इज गोइंग टू गिव अस स्पीड. इज दैट करेक्ट? ठीक है. नाउ देयर आर सर्टेन थिंग्स वी कैन नॉट फिगर आउट फ्रॉम द डिस्टेंस टाइम ग्राफ. ठीक है, व्हाट आर दोस? From a distance time graph, we cannot predict the direction of motion. Can we predict the direction of motion? We cannot predict the direction of motion. Is that correct? Do you agree? Can we predict the direction of motion? Obviously, we cannot predict the direction of motion because we have no idea about the direction of velocity. ठीक है, speed मेरे को direction तो नहीं बताता है ना. So we cannot predict what is the direction of motion. From a speed time graph, we cannot predict the direction of motion. Correct? Also, we can tell whether a particle is accelerated or decelerated. ध्यान से सुनना statement को. We can tell whether a particle is accelerated or decelerated. How? Because we know how the speed is changing. If the speed is increasing, the particle is accelerated. If the speed is decreasing, the particle is decelerated. So we can tell whether the particle is accelerated or decelerated, but we cannot tell the direction of acceleration. We will have no idea what the direction of acceleration is. Do you agree to this? Do you understand this? ठीक है? Because I have no idea about the direction of the particle. I can say that the speed is increasing or decreasing, but I have no idea in what direction the particle is moving. Okay? So I cannot tell the direction of acceleration. Is that correct? Clear? Any problem? चलो, perfect. तो now we are going to quickly look at a question. फटाफट ये क्वेश्चन करते हैं. It's a very easy question. फटाफट इसको सॉल्व करते हैं. Draw a distance time graph for a particle thrown vertically upwards. ठीक है? So this is the particle. It is thrown up with a velocity u under gravity. So obviously it is going to go up and then it is going to, it is going to come down. So we have to draw the distance time graph. ध्यान से सुनना, not the displacement time graph. We want the distance time graph. Disha is saying, sir, I have to leave. कुछ काम है. कोई बात नहीं Disha. ये session, after the session you can watch it also. No worries. Atharv is saying from where notes can be downloaded. Atharv, you go in the description box. There is website link. ठीक है? Website link. वो website link से क्या करोगे? वो website link पे click करोगे. So there you will see that you will get the PDF notes, you will get the DPPs, and after the test is completed, you will get the chapter test also. ठीक है? Increases convex, then increases concave. Yes, 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 absolutely. ठीक है? So when time was zero, the particle will have no distance covered, obviously. ठीक है? When time is u by g, half of the time of flight. ठीक है? Half of the time of flight. Then what is the distance covered? The distance covered is h. Matlab we know this point. ठीक है? Correct? Okay. Now after the time of flight has been completed, after 2u by g, okay, which means that the particle has come back to its original position. Now what is the distance covered now? Is the distance covered 0 or 2h? I'm talking about the distance. It has gone up h and it has come back h, which means that the distance covered is 2h. The distance covered is 2h. Now the point is, how do we join these points? Okay, how do we join these points? So first tell me, from 0 to h, how do we join these points? We can join these 2 points in 3 ways. We can join these 2 points with a straight line. We can join these points like this, and we can join these points like this. बताओ मेरे को 1, 2 और 3 में कौन सा होगा? Tell me. Prakhar is saying straight line. Prakhar, सोचो, distance time graph है. 1, 2 or 3. How should we join these 2 points? 1, 2 or 3. Prakhar is saying 1. Okay. Majabin is saying 2. Hidden is saying 1. Frankie is saying 1. Majabin is saying 1. अरे Majabin आंसर बदल लिया यार. सब पॉलिटिशियन बन गए यहाँ पे. कोई अपनी बात पे नहीं रह रहा है. Vedant is saying 1. Satyam is saying 3. Anmol is saying 1. ठीक है. सबसे पहले आराम से. Let's talk about whether it will be a straight line or not. Now distance time graph. If it is a distance time graph, the slope is going to give us what? The slope is going to give us speed. And if it is a straight line, it means that the slope is constant, which means that the speed is going to be constant. When a particle is thrown upwards, is the speed going to be constant? No, the speed is not going to be constant. तो straight line तो बिल्कुल नहीं हो सकता है. आ रही बात समझ में? It cannot be a straight line. Straight line का मतलब हो जाएगा that the speed is constant, the slope is constant, matlab the speed is constant, which obviously is not going to be true. Now among 1 and 3, why do you say 1? Among 1 and 3, why do you say 1? Tell me, explain that to me. Out of the graph 1 and 3, why do you say 1, why not 3? Can you explain that to me? Decreasing slope. Very good, Hidden. Excellent answer. Because slope speed is decreasing. Perfect answer. Decreasing slope. Perfect. Ekdam sahi yaar. Ekdam sahi. When we are throwing a particle upwards, what is happening? The speed is going to decrease, na? The slope here is going to be higher. The slope will keep on decreasing. Is that correct? The slope will keep on decreasing. Hence this graph. Is that correct? Yes. And Swastika was very right when she pointed this out. Correct? Clear? हाँ, इसके बाद क्या होगा? You got it. इसके बाद क्या होगा? इसके बाद we'll have to join it like this. Because when it is coming down, the speed is increasing. Majabin is saying, और sir 3 किस सिचुएशन पे होगा? इस सिचुएशन में होगा. ठीक है? Now we have to join the वापस आने वाला journey. It has reached the highest point. Now it is coming back. Now when it is coming back, what is going to happen? When it is coming back, what is going to happen? ठीक है? The speed is going to increase. So the graph is going to be like this. Because the speed is increasing. The slope is increasing. अनमोल समझ में आया? क्या सेंटर ऑफ मास ऑफ सर्कुलर डिस्क? अनमोल मतलब तुम यहाँ पे टाइम पास करने आ रहे हो क्या? आर वी टॉकिंग अबाउट सेंटर ऑफ मास? वी आर टॉकिंग अबाउट ग्राफ. चलो सब टाइम पास मत करो यार. At the highest point the speed is 0 for some time. Yes, correct. At the highest point the speed is 0 for some time, and then the speed is going to increase. So speed is going to increase. That is why this kind of graph will be there, because the slope is increasing. Is that correct? Chalo, clear hai? Perfect. All right, मतलब distance time graph and displacement time graph, we are through with that. You guys have got the concept very well, ठीक है, and you were answering all the questions. सारा clarification हमने कर दिया. वेदांत बोल रहा है एक बार डिफरेंशिएशन के साथ समझाओ, एक बार डिफरेंशिएशन के साथ समझाओ. व्हाट डज दैट मीन वेदांत? डिफरेंशिएशन क्या है? स्लोप ही तो है. थिंक अबाउट इट वेदांत, व्हाट इज डिफरेंशिएशन? डिफरेंशिएशन इज स्लोप इटसेल्फ. करेक्ट. And what does the differentiation of a distance time graph give us? It gives us the slope. So all we have to do is we have to look at how the slope is changing. यही तो है. Differentiation क्या है? It's just the slope. Correct. चलो. Next we want to talk about the velocity or the speed time graph. ठीक है, तो फटाफट करते हैं. Velocity time graph से क्या क्या पता चलता है? Guys, tell me quickly. What all do we get from a velocity time graph? Quickly बताओ. So obviously the slope of the velocity time graph gives us acceleration. The slope of the velocity time graph gives us acceleration. Yes. And there's one more thing. The area under the curve, जिसको हम बोलते हैं integral of v dt. The area under the curve gives us, what does it gives us? It gives us the displacement. Is that correct? Correct? ठीक है? So the slope of the velocity time graph is going to give us the velocity. And the area under the curve is going to give us the displacement. Be very careful that it gives us the displacement. Is that correct? ठीक है? Alright. So again what I'm going to do is I'm going to throw questions at you and you are going to quickly answer, ठीक है, about what is the nature of this velocity time graph. ठीक है? Ready? Ready? चलो, let's start with direction of motion. And also give me the answer why. Let's talk about the direction of motion. Direction of motion is positive or negative? Quickly guys. Chalo, chalo, chalo. Direction of motion? Positive या negative? Also tell me the answer, reason. Also tell me the reason. Because velocity is uniform. Satyam, if the velocity is uniform, does it mean it needs to be positive? Think about that. If the velocity is uniform, does it necessarily mean that it needs to be positive? Arya is saying positive. Yes, correct. Positive hai. But tell me why? Why is the catch over here? Why is the velocity positive? Why do you say that the velocity is positive? Positive velocity as it is above the x-axis, t-axis. That's what you meant. हाँ, ये हुई ना बात. Simple सी बात है. This is above the t-axis. ठीक है? If this is above the t-axis, velocity is positive. इसको कहीं भी बनाओ, ऐसे बनाओ, ऐसे बनाओ. It is always above the t-axis. So what does it mean? If it is above the t-axis, the velocity is positive, which means that the direction of motion is going to be positive. अब मेरे को acceleration के बारे में बताओ. Constant or variable? Constant acceleration, acceleration is actually 0. ठीक है? Correct. Now the slope, what is the slope? The slope is 0. The slope is 0. Is that correct? And if the slope is 0, it means that obviously this is constant. The acceleration is going to be constant. ठीक है? Acceleration is going to be 0. Correct? ठीक है? Here what do we see? That the slope is 0, which means the acceleration is 0. अब acceleration 0 है, तो motion कैसा होगा? Motion uniform होगा. So type of motion is going to be uniform. ठीक है? The particle is neither accelerated nor decelerated. And obviously the acceleration को constant बोल सकते हैं because 0 is also a constant. ठीक है? Now tell me about the displacement. Positive displacement या negative displacement? Positive displacement positive. Yes. This is the area under the curve. Correct? So if the area under the curve is above the t-axis, we are going to take it as positive. So the displacement is positive. Perfect. Well done. Chalo. Next. Chalo. Direction of motion. R is I think Satyam, there's some typo over there. I don't understand what you're saying. Chalo. Direction of motion, positive or negative? Fatafat. Kedar is saying negative. Swastika is saying positive. What is the direction of motion? We only have to think about the direction of velocity. अब ये क्या है? This is a velocity time graph. Positive motion. Why positive motion? Tell me, why positive motion? Rakhi is saying positive. Nikhil is saying positive. Very good. Why positive? Simple सी बात है ना? Tell me why positive? Above the t-axis. Simple सी बात. ठीक है? Now we are talking about velocity. This is a velocity time graph. If it is above the t-axis, the velocity is going to be positive. ठीक है? So the direction of motion is positive. Correct. What about acceleration? चलो acceleration क्या है? Negative, positive? Acceleration क्या है? Is it negative? Is it positive? Sorry, I'm sorry. Acceleration, is it constant or variable? Acceleration, I'm talking about constant or variable. ठीक है? Is the acceleration constant? Is the acceleration variable? Constant. 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 Very good. Why constant? Because the slope is constant. The slope gives us the acceleration and the slope is constant. So the acceleration is constant. Now tell me, acceleration positive or negative? Acceleration positive or negative? Negative. Very good. Why is acceleration negative? Because the slope is negative. The slope is making a obtuse angle with the t-axis. Okay? So the acceleration is negative. Now tell me the type of motion. Accelerated or decelerated? Accelerated or decelerated? Think about it and tell. And if you are giving me the answer, give me the reason as well. If the motion is accelerated or decelerated. Some people are saying uniform motion. Some people are saying constant. Think about it again. Decelerated motion. Why? Swastika, बताओ ना. Because the slope is decreasing. Frankie, slope किधर decrease हो रहा है? Slope किधर decrease हो रहा है? Graph is going down. Decelerate. Velocity is positive. Acceleration is negative. वो सब समझ में आ गया. But अच्छा. Oh, that's what you're saying. Velocity is positive. Acceleration is negative. ठीक है? That is also a correct way of saying it. That is also a correct way of saying it. प्रखर बोल रहा है slope same है. Constant acceleration. ठीक है? आराम से. Is the motion accelerated or decelerated? What does it depend upon? Answer this. The motion is accelerated or decelerated. What does it depend upon? बस खत्म स्वास्तिका. इतना ही तो मैं पूछ रहा था. स्लोप से कोई मतलब ही नहीं है. Are we talking? स्लोप से कोई मतलब ही नहीं है. What is happening? Slope तो acceleration दे रहा है ना. We are talking about whether the motion is accelerated or decelerated. मतलब the speed is increasing or decreasing. अरे बाबा यहाँ पे ये speed है. What is happening to the speed? The speed is decreasing. आई बात समझ में? ठीक है? Yes. बस इतनी सी बात है. कहाँ हम लोग slope पे चले गए? कहाँ displacement पे चले गए? Simple सी बात है. How do we check whether a particle is accelerated or decelerated? Speed. How is the speed changing? The speed is decreasing. मतलब this is decelerated motion. खत्म बात. प्रखर बोल रहा है सर टाइप ऑफ मोशन को एक्सेलरेशन से लिंक करना गलत है. क्यों गलत है? Accelerated or decelerated? I'm not talking about the direction. I'm talking about the type of motion. The type of motion could be uniform motion. It could be accelerated motion or it could be decelerated or retarded motion. Correct? चलो, displacement positive या negative? Displacement positive या negative? केशव, hi sir. केशव, जब सेशन एंड हो रहा है तब आ रहे हो? अरे displacement negative आ रहा है. Displacement negative. Think about it. Displacement negative या positive? Positive. Rakhi, negative. Displacement positive. ठीक है, सिंपल सी बात है, आराम से समझो. What is the area under the curve? This is the area under the curve. ठीक है, अब if this is the area under the curve, is this area above the t-axis or below the t-axis? It is above the t-axis. Truly Satyam is absolutely right. Yes, so it is above the t-axis, which means that the displacement is going to be positive. आई बात समझ में? Clear है अब? Any problem? चलो next. अब बताइए. Velocity is positive, that's why displacement is also positive. हाँ, ये भी बात सही है स्वास्तिका. That is also correct. Clear? Now tell me about this graph. What is the direction of motion? Positive or negative? What is the direction of motion? Direction of motion is changing. Yes. Ayush, from negative to positive. Excellent. Negative to positive. Excellent. So यहाँ से यहाँ तक the velocity was below the t-axis, and after that it was above the t-axis. So we'll say first negative, or we can say from negative to positive. So कहीं ना कहीं यहाँ पे velocity became zero. आई बात समझ में? So first velocity was negative, means the particle was going in the negative direction, then it stopped and then started moving in the positive direction. Is that correct? Perfect. Now tell me about the acceleration. Constant or variable? Acceleration, constant or variable? Quickly guys, quickly. Arya is saying variable. सोच के बताओ आर्या. Majabin, constant. Ayush, constant. Keshav, constant. Why constant? Why constant? Why constant? Because the slope is constant. Beautiful. See, the slope is constant. It's a straight line. It's a linear variation. It's a straight line, which means that the slope is constant. So acceleration is constant. Yes, acceleration is constant. And what is the slope? The slope is positive as well. It is making a acute, not acute angle, acute angle. Okay? It is making an acute angle. So the acceleration is positive as well. Is that correct? Yes. Type of motion, accelerated or decelerated? Batao. Type of motion, accelerated or decelerated? Accelerated. What is the type of motion? Accelerated or decelerated? Accelerated because velocity is increasing. Accelerated. Accelerated. यहीं पे फंसते हैं लोग. हाँ, सनी ने कुछ बोला. सनी कुमार बोला सर बोथ. सनी, कैन यू एक्सप्लेन योर आंसर? स्वास्तिका बोली शुरू में डिसेलरेटेड देन एक्सेलरेटेड. हाँ, नाउ यू आर गेटिंग इट. नाउ यू आर गेटिंग इट. देखा, फंस गए ना? सो इन द फर्स्ट ट्राई फंस गए थे. नहीं फंसना है. यू गाइज नो द कॉन्सेप्ट. सो व्हाट इज हैपनिंग? स्टार्टिंग में द स्पीड इज डिक्रीजिंग. है कि नहीं? यहां पे कुछ स्पीड थी, स्पीड डिक्रीज होते होते जीरो हो गई. ठीक है, अब उसके बाद क्या हुआ? उसके बाद स्पीड स्टार्टेड इंक्रीजिंग. इज दैट करेक्ट? सो फर्स्ट इट इज डिसेलरेशन, then it is acceleration. So first deceleration, then acceleration. Is this clear guys? नहीं फंसना है. But speed तो बढ़ रही है ना. आर्या सोचो. Let's give values over here. Let's call this -10. Let's call this 10. Now understand what does -10 mean. Arya, understand what does -10 mean. -10 is the velocity, meaning the speed is 10 meter per second, but it is going in the negative direction. But what is the speed? The speed is 10. आई बात समझ में? What is the magnitude of velocity? The magnitude of velocity is 10. फिर क्या हुआ? फिर -9, फिर -8. What is happening over here? पहले velocity was, the magnitude of velocity was 10, फिर 9, फिर 8. What is happening? Is the speed decreasing or increasing? The speed is decreasing. आ रही बात समझ में? The speed is decreasing. And after this point, what is happening? Now 1, 2, 3. Now the velocity is, the magnitude of velocity is 1, 2, 3. What is happening? The velocity is increasing. आई बात समझ में? So this answer is absolutely right. Deceleration and then acceleration. Is that correct? Clear? Now tell me about the displacement. Quickly tell me about the displacement. Displacement 0 लग रहा है. Displacement 0 लग रहा है. Obviously it will depend upon the time. Let's say I call this 2 second and let's say I call this 4 second. अब बताओ. Displacement 0. हाँ, now we can say. Yes, now we can say. So this area is going to be what? This area is going to be negative because it is below the t-axis. So we'll say this is negative displacement. Correct? It is below the t-axis. That's why we are calling it the negative displacement. It is above the t-axis, so we are calling it positive displacement. Is that correct? Okay? So negative displacement, positive displacement. So from this graph, because this is 2 second and this is 4 second and it's a constant slope, so we can say that the negative area and the positive area are going to be equal in magnitude. So they'll cancel out. Correct? Clear hai? Okay? So the displacement is first negative. Displacement is firstly negative and positive but not necessarily 0. Frankie, you are absolutely right. But now I have given the values. इसको मैंने 2 second बोला है, इसको मैंने 4 second बोला है. दिख रहा है? If I had not given the values, then it was not, then you would not have been able to tell. But now if I have given values, तो 2 second, 4 second मैंने value दे दिया, मतलब the positive area and the negative area are equal in magnitude. They'll cancel each other. ठीक है? यहीं पे अगर मैं तुमसे distance पूछता तो क्या करते? What would you do if I would have asked about the distance? Tell me. What you would have done if I would have asked about the distance? ठीक है? तो इसमें केस में क्या करते? Let's say this is area 1 and let's say this is area 2. So the distance would have been the mod of area 1 plus the mod of area 2. Correct? ये पता है ना? Yes. So from a velocity time graph, we can also find the distance. All we have to do is, all the areas, we have to take the mod and add them. Correct? So we'll get the distance also. Clear? Chalo. Last one guys, quickly. Give me all the answers. चलो एक एक करके चलते हैं. Direction of motion, quickly. Positive or negative? Truly Satyam is saying positive. सोच के बोलो. Truly Satyam. Direction of motion, positive or negative? Negative. Positive to negative. Negative to positive. हर तरह का आंसर आ रहा है. All kinds of. Firstly positive, then negative. Yes, positive to negative. देखो, what is happening? यहां से यहां तक the velocity is above the t-axis, which means the velocity was positive. After this, the velocity is below the t-axis, then it is negative. So the direction of motion is positive to negative. यहाँ पे velocity 0 हुई. So first it was moving in the positive direction, it stopped and started moving in the negative direction. Correct? Okay. So the direction of motion is going to be positive to negative. Acceleration, constant or variable? Acceleration, constant or variable? Variable acceleration. Absolutely, variable acceleration. Why variable acceleration? Tell me. Why variable acceleration? Because the slope is changing. Yes, the acceleration is going to be variable because the slope is changing. यहाँ पे slope ऐसा है, यहाँ पे slope ऐसा है. So the slope is variable, which means acceleration is variable. Yes, very good, very good. Now tell me, acceleration positive or negative? Can you tell me the acceleration is positive or negative? Negative acceleration. Tell me, acceleration, negative or positive? I'm not talking about accelerated motion or decelerated motion. That is the next question. Right now I'm asking, what is acceleration? Meaning positive or negative? Meaning the direction of acceleration. Negative. Negative. नेगेटिव, अरे बार बार मत लिखो, आई अंडरस्टूड. Negative. Dory is saying positive. Again, guys, don't get distracted. Slope, acceleration कौन देता है? From a velocity time graph, what gives you the acceleration? The slope gives you the acceleration. So all we have to see is whether the slope is positive or negative. Yes. तो चलो यहाँ पे slope बनाते हैं. यहाँ पे slope बनाया. Is it making acute angle or obtuse angle? It is making obtuse angle. मतलब the slope is negative. ठीक है. यहां पे देख लो, यहां पे what angle it is making? It is again making what angle? Obtuse angle. So the slope is still negative. आ रही बात समझ में? Clear? ठीक है. So the slope is always negative. That is why we are saying that acceleration is going to be negative. Okay? The slope is always negative. Correct? Now the question is type of motion, accelerated or decelerated. Now you should get this right. Now what is it? Is it accelerated motion or decelerated motion? Quickly guys, we don't have much time. We have already overshot the session. शुरू में डिसेलरेटेड फिर एक्सेलरेटेड. परफेक्ट आंसर, परफेक्ट आंसर. एक्सेलरेटेड टू डिसेलरेटेड नहीं, उल्टा 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 उल्टा. सी व्हाट इज हैपनिंग? हाउ डू वी फाइंड एक्सेलरेटेड और डिसेलरेटेड? बाय द स्पीड, बाय द मैग्नीट्यूड ऑफ वेलोसिटी. तो मैग्नीट्यूड ऑफ वेलोसिटी क्या हो रही है? पहले इट इज डिक्रीजिंग, इट इज डिक्रीजिंग. द मैग्नीट्यूड ऑफ वेलोसिटी इज डिक्रीजिंग. सो दिस इज deceleration. After this, what is happening? The magnitude of velocity is increasing. Is that correct? The magnitude of velocity is increasing. So this is acceleration. आई बात समझ में? So first, what do we say? We say that first deceleration, then acceleration. ठीक है, इसमें कंफ्यूज नहीं होना है. डिसेलरेटेड मोशन और एक्सेलरेटेड मोशन यू विल हैव टू सी बिकॉज ऑफ व्हाट? वी विल हैव टू टॉक अबाउट द स्पीड, द मैग्नीट्यूड ऑफ वेलोसिटी. हाउ इज दैट चेंजिंग? ठीक है. लास्ट, डिस्प्लेसमेंट पॉजिटिव और नेगेटिव. ठीक है, यहां पे क्या मिल रहा है? पॉजिटिव डिस्प्लेसमेंट. यहां पे क्या मिल रहा है? नेगेटिव डिस्प्लेसमेंट. मतलब ओवरऑल द डिस्प्लेसमेंट इज गोइंग टू बी नेगेटिव. इज दैट करेक्ट? ठीक है. So the displacement in this case is going to be negative. Majabin is asking direction of motion, type of motion बताना. Majabin, watch this video again. ठीक है, we are short of time. I'm so sorry. Watch this video again. 100% you will understand. All right. तो चलो. So I'm going to wrap up the session today over here. Okay. Next session we'll continue our discussion and we'll move forward with graphs. There's a lot of stuff remaining in graphs. Okay. So agar you enjoyed this session today, it was a different way of learning today because I asked you a lot of questions and you answered a lot of questions. So because of this interaction, you also guys enjoyed it. I also enjoyed it. So I'm going to make the session more enjoyable in terms of our interaction. ठीक है. तो चलो, if you like the session, give us a like. Okay, like the video, share it with your friends, and that is going to mean a lot to us. Alright, chalo. Alright, so I'm going to sign off now guys. Thanks a lot for watching. I'm going to see you in the next session. When? Friday 12:30 PM. Alright, याद कर लेना, reminder लगा लेना, Friday 12:30 PM. Alright, chalo. Take care guys. Bye bye. Thanks for watching. See you soon.